Okay guys, so today we're going to be looking at lesson 4.2, solving one-step inequalities with addition and subtraction. If you don't have paper in front of you, please pause the video and get yourself some lined paper or scrap paper now to do some practice problems on. To get started with this, you literally are doing the exact same thing we did when we were solving one-step equations. Our goal is still just to isolate that variable, and the way we isolate the variable is by using inverse operations. In the past with equations, we would just keep our equal sign. Now we're just keeping whatever inequality sign is given to us to begin with in the problem. So if it's less than, it's going to stay less than. If it's greater than, it'll stay like that. Let's look at this first example. So it says solve x minus 5 is less than negative 3. Again, remembering that my goal is to isolate x. So I want x to be all by itself, which means I need to get rid of this minus 5. To get rid of a minus 5, I'm going to add 5 to both sides. By doing that, I can cancel this out. And that leaves me with just x is less than positive 2. Negative 3 plus 5 is positive 2. Then it asks me to graph my solution. So I'm going to just kind of write myself a 0 here. I'll put the 2 and I'll put the negative 2. Just kind of make yourself quick number lines. You don't have to go and like number everything from 0 to 10 and 0 to negative 10. Remembering that if I have a less than sign, that means I'm going to have an open circle on 2. And if it's less than, I'm going left. So that would be the graph of my solution. Okay, let's look at some more examples. If we go to this one, 13 is less than or equal to x plus 14 and graph its solution. Again, I'm trying to isolate x, which means I need to get rid of a plus 14. I get rid of a plus 14 by subtracting 14 from both sides. That allows me to cancel this out, leaving me with negative 1 is less than or equal to x. Now, you can rewrite this if it's easier. This is the way my brain works. This is not what everybody needs to do, but sometimes it's better to have the variable first, so you just kind of read it backwards. So instead of negative 1 is less than or equal to x, if I read it backwards, I would say that x is greater than or equal to negative 1. So you're kind of just starting at the x and writing it in the reverse form. When you graph it then, I'm going to just put my negative 1, my 0, and my 1. I have greater than or equal to negative 1, so I'm going to have a closed circle. Okay, and my arrow is going to be going to the right. Those are the number greater. If I look at this way, this is saying that negative 1 is less than or equal to x. That means all the values have to be greater because negative 1 is less than or equal to what we're looking for. So these are the exact same inequality. Whatever makes more sense for you is fine. Okay, what I'd like you to do is try to pause the video and solve these 3 inequalities. If you're able to, graph the solution as well, and then we'll be going over them. Okay, so let's get started. I'm going to just kind of reveal the answers. So for number 1, I'm going to add 6 to both sides to get rid of that minus 6. That leaves me with y is greater than negative 1. For number 2, I have to get rid of a negative 3.8, so I'm adding 3.8 to both sides. B is less than, oh, I'm sorry, that's actually a little error. B should be less than or equal to 5.5. And then for number 3, 18 is greater than z minus 4. I'm going to add 4 to both sides, so 22 is greater than z. Or again, if you want your variable first, that would tell me that z is less than 22. Okay, now let's look at graphing these solutions. Looking at number 1 to begin with, I have a negative 1, a 0, and a positive 1. Y is greater than negative 1. That means I'm going to have an open circle, and my arrow is going to go to the right. These would be all the numbers that are greater than negative 1. Okay, for the next one, again, let's start at 0. This would be 2, 4. This would be 5, so 6 would be about here. So if I'm looking to graph 5.5, that would be right around here. It's less than or equal to, so I'm going to have a closed circle. And if it's less than, I'm going to the left. I'm just going to write in my 5.5 so we know that that's where it's going. Okay, and for the last one, Z is less than 22 or 22 is greater than Z. So I'm going to just start, I'll just do a quick kind of number line here. Let's call this one 20, 22, 24. Because Z is less than 22, I'm going to put an open circle and I'm going to go to the left. This is also telling me that 22 is something greater than whatever Z is. So that would have to be as high as you can go. Okay. All right, let's just look at one word problem example. It says at an orange picking farm, you are allowed to pick up to 40 oranges a day, and you already picked 17. Find the possible number of oranges you can still pick today. So the most important word here is that up to. That means that I cannot pick more than 40. It has to be 40 or less. So that means whatever's on this side of my inequality is going to end up being less than or equal to, because it could be 40. Now, what am I doing to get there? I have 17 oranges. I'm going to pick a bunch more, so I'm going to add those together. And when I combine them, it has to be less than or equal to 40. So to solve this, I'm going to subtract 17 from both sides. Okay, leaving me with just x over here being less than or equal to 23. Okay, if you need extra support, feel free to reach out. You're going to work on a quizzes assignment that's posted. Also, you can use your Big Ideas Online textbook and any other resources that you can find. Good luck.